Wave optics. Various theories about nature of light. Newton corpuscular theory says that light consists of tiny particles called corpuscles. Wave theory says that source of light sends out disturbance in all directions. Electromagnetic theory says that light travels in the form of electric and magnetic field mutually perpendicular to each other and perpendicular to direction of motion. Planck quantum theory says that light travels in the form of small packets of energy called photon. De Broglie theory says that light possesses dual nature. The locus of all particles of the medium which are vibrating in same phase is called wavefront. It is of four types: spherical wavefront, cylindrical wavefront, plane wavefront, converging or diverging wavefront. If source of light is point source, then wavefront is spherical. If source of light is linear, then wavefront is cylindrical. When source of light is at large distance, then small portion of spherical or cylindrical wavefront behave as plane wavefront. Huygen principle is used to find the position of wavefront at any time. It consists of two assumptions. First, each point on the primary wavefront acts as a source of secondary wavefront, sending out disturbance in the same manner as the original source of light does. Second, the new position of the secondary wavefront is the outer envelope of secondary wavelets. The only drawback of Huygen principle is that it considers that there is no backward flow of energy. We can derive laws of reflection on the basis of Huygen principle. We can also derive the laws of reflection on the basis of Huygen principle. We can draw the diagram of plane wavefront after reflection from concave mirror and after refraction from prism and convex lens. Two sources are said to be coherent if they emit waves of same frequency, same wavelength and same phase or constant phase difference. The condition is that two sources should give monochromatic light and path difference between two waves should be small. When two or more waves traveling in the medium superimpose each other, then the resultant displacement is equal to vector sum of displacement due to individual waves. The phenomena of non-uniform distribution of energy in a medium due to superposition of light waves from two coherent sources is known as interference. When crest of one wave fall on the crest of other wave, then the amplitude and hence the intensity of the resulting wave is maximum and energy is maximum. This interference is said to be constructive. These points are bright. When crest of one wave fall on the trough of the other wave, then the amplitude and hence the intensity of resultant wave is minimum, energy is minimum. These points are dark and interference is destructive. The interference pattern in which position of maximum and minimum does not change with time is called sustained interference. For sustained interference, source should be narrow, should be close, should be coherent, should emit wave continuously, amplitude should be same, phase difference should be same and screen should be at large distance. Phase difference is equal to 2 pi by lambda into path difference, where lambda is the wavelength. Due to interference of the wave, the resultant wave have intensity not only the sum of intensity of individual waves but also have another factor known as interference factor. For constructive interference, path difference should be integral multiple of wavelength. For destructive interference, path difference should be odd integral multiple of half the wavelength. Some important formulas. The distance between any two successive bright and dark fringes is called fringe width. Fringe width depends upon distance of screen from slits, wavelength of light used and distance between two slits. All fringes in interference pattern are of same width and are hyperbolic in nature. If monochromatic source is replaced by source of white light, then central fringe is white light surrounded by blue and red color and no clear fringe pattern is observed. If whole apparatus is immersed in a liquid, then fringe width decreases. Some important numerical based on interference. The phenomenon of bending of light around the corner of obstacle and spreading into the region of geometrical shadow is called diffraction. Diffraction takes place when size of obstacle is comparable to wavelength of incident wave. It is of two types: Fresnel diffraction and Fraunhofer diffraction. In Fresnel diffraction, source and screen are at finite distance and wavefronts are either spherical or cylindrical. In Fraunhofer diffraction, source and screen are at infinite distance and wavefront is plane. In lab, convex lenses are used between source and slit and screen to produce plane wavefront and to obtain diffraction pattern. In diffraction at single slit, the diffraction pattern consists of central maxima surrounded by secondary maximas, and the width of center maxima is 2 times the width of secondary maximas. Fringe width is equal to lambda capital D upon small d, where capital D is the distance of screen and small d is the distance between slits and lambda is the wavelength of light used. Center maxima is small for violet color due to small wavelength than red color. Interference is due to superposition of two wavelengths originating from two coherent sources, whereas diffraction is due to the superposition of secondary wavelengths originating from different points of same wavefront. In interference, fringes are large in number, equally spaced and have equal width, whereas in diffraction, fringes are few in number, unequally spaced. The width of central fringe is double the width of other maxima. The light which have vibration in all directions in a plane perpendicular to direction of propagation is called unpolarized light. The phenomenon of restriction of vibration of light vector in a particular direction in a plane perpendicular to direction of propagation is called polarization. The substances used to polarize the light are known as polarizers, for example, tourmaline crystals. By using the phenomenon of polarization, we can prove that light has got transverse nature. The crystal used to study the intensity of polarized light after polarization is known as analyzer. Malu's law states that intensity of polarized light transmitted through the analyzer varies as the square of the cosine of the angle between the plane of analyzer and plane of polarizer. Polaroid consists of a long chain of molecules aligned in a particular direction. Polaroids are used in sunglasses, camera filters, in window panes of aeroplanes and bullet trains, in automobiles, in 3D pictures, in LCDs, TVs, computers, and in solar compass, etc. Do one numerical, and thanks for watching.